Yeah, I think we should have done the solution for Prac 6 because this practical is actually you can do it in less than 30 minutes, this practical. Because the only thing you need to change is instead of using a fixed size array, you're going to use a dynamic array. So I'm going to open code blocks right now. Uh, totally forgot to take my mahi away. I guess I'll drink it after the session. So I'm gonna create a console application. Remember, you guys are doing console application, so meaning it runs on the terminal, right? So choose C++, then I'll just say practical 7 explanation. Then click next. Then just leave everything as default. Then click finish. Then you're gonna go to view. For me, I always remove it, so that's why I always have to go to view because I want it to be full screen so that you guys can see what I'm doing. So the only new thing that you need to understand about this practical, right? I'm sure Dr. Stung submitted a solution for practical 6. So it says that you must implement the same program. That means you're gonna copy and paste exactly the same thing you did in practical 6 and make only a slight changes. If I were you, right, if you didn't do well for practical 6, I would use Dr. Stung's solution, then make my own changes. So basically, I would take the header file and copy and paste the code, and take the CPP file, copy and paste the code that Dr. Stung wrote, then go to main.cpp, copy and paste the code that Dr. Stung wrote. Then from there, you start making the changes that they told you to make. That's how simple this practical is. They said you must use a one-dimensional dynamic array. So one-dimensional, meaning that we're looking at one dimension. If you understand maths very well, a Cartesian plane represents two dimension because we have two numbers to represent a point. So that we have x axis and y axis. So that would be 2D. That's a two-dimensional, right? But in this case, we're only working with one dimension. So you can think of it as like only focusing on the x-axis or only focusing on the y-axis. So let me make an example, right, of let me sort of like do the some sections of the practical. So they said your functions must be placed in a namespace named EA space, right? So let me make let's do this. Let me show you since it's Thursday. Let me be nice, Nyana, and show you some of the solution of this thing. The thing is, I don't have practical 6, right? Yeah, I would have to get practical 6. Can someone send me practical 6 via WhatsApp? Whether a personal, you send it personally or you send it via the group chat, that's up to you. Can someone send me practical 6? So what do I need? No, I need to go back to code blocks. Then I'm gonna create a file, a header file. So to create a header file, right, you're gonna click on file on the left, top left corner, click there, then you click on new, then you go to file, right? Because you want to create a new file. Then make sure it's clicked on files on this side. You click on files, but by default it should be clicked on files. Then you choose C or C++ header because we want to create a header file. Then you click go, then you paste the name here, which is libevo.alg.h. Then if you leave it like this, it's not gonna work because your header file is not included into your project. To include it into your project, basically into this code blocks project, I have to click these three dots over here, then just click save. Then now you see that it shows the location, right, of my project. So now it's added part of this project. I like to remove the underscore included because Prof. Kuta taught me that way. And I feel like it's good to look, it makes your header file a bit neater. You don't have to remove it there, that's fine. You can just leave this part empty. That's fine. Me, I like to remove it. Then make sure you click all. If you don't click all, you won't be able to essentially run your header file. So you need to click all here, then click finish. Then there's the header file. If you're using VPL, you have to cram all of these things by head because VPL, there's no option to create a header file. So yeah, you need to be very careful of which which approach you choose when you write semester test 2. Are you gonna use VPL or code blocks? If you're using code blocks, don't forget to save it to what we call the T drive. I'll make an example when you do semester test 2 revision. So I'm gonna create another file. So I'm gonna click on files. Now we want the CPP file. Another word for a CPP file, right? Or a .cpp file, it's C++ source code. So therefore, I'm going to choose C or C++ source. Click there, then click go, then choose C++ because that's the language you're coding in. Then paste the name that I was instructed to use to create my source file. Then I'm going to click the three dots, then click save, and then click all, and then click finish. Then now, if I want to make use of let me do this. Let me quickly check. I hope someone sent me the practical. Let me open my WhatsApp. Okay. I didn't want the solution per se. I didn't really want the solution, but that's okay. I wanted the question paper. Can you guys send me the question paper? Can someone send me the question paper? Are you guys finding the question paper? I'm still waiting so that we can continue because I wanna look back at that question paper. Then I'm gonna answer some questions from there. I'm still waiting, guys. It shouldn't take you a lot of time to send this thing. I don't want the solution. I want the practical, the question paper, the PDF. Okay, I got it. So let me save it. Save and then close. Let me share my screen again. No want you reading my chats. So share. So yeah, let's go to the PDF. Practical 6. So this is the practical 6, right? So for practical 6, you're doing something that I call mutation and recombination. If you did life sciences, you'd understand better. But I didn't do science in high school, so I don't know. Me, I just know what it's supposed to do. That's all that matters to me. So you're supposed to use two fixed length, one-dimensional arrays, right? The keyword here is fixed. A fixed array, it means that once you give it a size, that size will never change. It's fixed. It will always be the same. It's like constants, just like the constant pi. Pi will never change. Pi will always be the same value. So that's basically what they were talking about there. So I'm going to do the example of this solution for this before we go back to practical 7. So let's quickly do the solution for this, right? So the solution is that you need to have, it's up to you, but I would advise you create functions for this. You need to have a function that does the mutation. You need to have a function that does the recombination. So, but before we do all of that, remember that they said each array will be made up of random numbers, which are either 1 or 0 at each index, meaning that I have to use a for loop to go through each position in the array. So if you are not new, it's fine. We did talk about that. You should understand a bit better. But if you're still new, it's fine. Like you recently joined the group. It's cool. I'll send you the recordings of the sessions that we've had so far. Then you catch up on that. So they said the namespace should be EA space. For this question paper, they didn't tell you to use a namespace, right? I don't see where it says a namespace. Oh, hey, Mara, why do they use dark colors? Why can't they? Yeah, when you give nerds a mission to do documents, they're just plain and boring. So I'm gonna say namespace, EA space, right? So this is how you create a namespace. What's the whole purpose of a namespace? We did talk about that, but then in simple words, a namespace, right? It's a way to allow us to create this, to use the same variable name in the same application. So for example, I can come here and create my own variable. Let's say int num like this. Then I create another different namespace, right? I'm gonna call it space. I create a different namespace, and then I have int num again. So how will C++ know the differences between which num variable is from the EA space and which num variable is from the space namespace? You simply, when you call it, you're gonna pass the name of the namespace first. So EA space colon colon, which means go into it, basically go inside the namespace. This is what those two colons mean. And you see it's already giving me suggestions. So I want to access num, the num variable. Then done, right? This will be the num variable. Then to call the num variable from the namespace space namespace, I just simply use the name of the namespace, which is space, then colon colon to say that I want to go inside the namespace to access this variable called num. That's the only reason we have a namespace. That's literally the only reason for it. But then they want you to become good programmers, so they want you to use these techniques, right? So if you look at your practical, right, step number one, what's the first step? Step number one is that you need to the last statement here in the first paragraph, in the second paragraph, right? The last sentence, which is each array will be made up of random numbers, which are either 1 or 0 at each index. So that's the first step. We need to initialize the array. So I need a function called initialize array. So I'm gonna say void. Why void? Because the function all it does is to initialize the array. So I shouldn't expect to get back anything. So I'm gonna use void. So void initialize array. Dr. Strong said init array. That's fine. People have different ways of naming things. Like I said, like I always say to my students, don't cram the solution because you need to do it in your own way or your own way of thinking. Don't just because Dr. Strong called it init array, it doesn't mean it will only run when you call it init array. No. You can call it initialize array or setup array. That's up to you. You can even call it setup array. Just to show you that it's going to work either way, I'm going to actually rename it. Just call it setup array. But you should actually call it initialize because it doesn't really matter. It's fine. I'll just call it setup array. Then you pass the array you want to set up. Remember, they told you that we have two fixed arrays, right? And they are one dimensional, meaning there's one square brackets. If you remember arrays, right, we did talk about them. So to create an array, you say int num, after the variable name, you specify the square brackets. Each square bracket that you specify represents one dimension. So if there's one square, it means it's a one-dimensional array. If there's two squares, it's two-dimensional array. If there's three squares, 3D, and so forth. You get the idea. So in my case, I need to pass in an array. It's up to you what you call the arrays, to be honest. It doesn't really matter. But just be very careful of something. Let me say array. You see, if I use the keyword array, you see that it turns into this green color, right? Meaning it's already reserved. Basically, it's already being used by C++, this name. So I have to come up with a different name. So I'm gonna say what do we call this thing? We have mutation and recombination. It's fine. I'll just call it array as ARR, right, for array. So I'm gonna say ARR. But before you do that, you need to specify the data type. So int, it's an array of integers. How did I know that? Because the practical said so. You see, 1, 0, 1, these are integers. Then the name of the array, which is, I'm just gonna say ARR, square brackets to specify or tell C++ that, listen, this is an array. Then in C++, if you read the textbook, right, you always need to pass the array itself, comma, and the size of the array. Basically, how many elements are in the array. Remember, an array is we did talk about arrays. It's a container of multiple boxes. So you need to specify also pass in a parameter that explains how many boxes are there. So int length, we're going to call it length. Why am I choosing length? Because if you use the name size, right, you see it becomes green, meaning it's already used by C++. Don't use that name. So I'm going to call it length instead. Then this is for setting up our array. And remember the header file, it's where you put in your function prototypes. That's why I'm ending it with the semicolon. You should only put function prototypes. And the question paper also told you should create these functions inside the namespace. So that's why they're being put inside the namespace. Then if I go back to my practical, what's the second step? So after setting up our array, we're going to have a mutation function to do the mutation. We're going to have a recombination function to do the recombination. So let's look at the mutation. A mutation is a simple task. If a number in the array is a 1, you change it to a 0. If it's a 0, you change it to a 1. So that's how simple it is. So you see that if the array is like this, you change every 0 to a 1 and every 1 to a 0. So that means we are changing an array. So that means I'm expected to pass one array. So it's gonna be void again, because to be honest, most of these functions are gonna be void because you don't return anything. But if it has a function, let's say it's a function called calc average, we should return the average. So that those type of functions would return something. But in this case, all of the functions we're gonna have are gonna be void. So I'm gonna say void. Um, you should. I want you to. You see when naming a function, right? In a question paper, when you have a question paper and you're doing past paper, whatever, especially in second semester, for now it doesn't really matter. But variables, to name variables, you use what we call nouns, right? For example, int number. The word number is a noun. So we use nouns to name variables. Functions, you use verbs. That's why you see my function, I called it set up array. It needs to start with the verb. So it starts with the word set, which is an action. Remember they taught you in high school, verb is a what? Doing word. Setting something it's an action. For example, their parents tell you, can you set up this thing for me? That means you have to walk and go do the setup, which is an action. So that's why I use the word setup. Then the second one would be mutate, right? I can just call it mutate or mutation, right? It's up to you, or recombination. Yeah, that's up to you how you create it. But the mutate is a mutation is a verb, right? It's an action. You're changing something. From the life science perspective, you should understand what mutation means. So int arr, we are taking an array and its length. And if you read the practical, there's only talked about one array. So that's why I'm passing one array. Then now when you do a recombination, now it starts to get a bit interesting. When you look at recombination, they say recombination is also a simple task, but it involves two arrays. Learn to read instructions. They told you that it involves two arrays. So that means the function we're going to create needs to take in two arrays. The user will have to specify an index that represents the point at which crossover must be performed, right? The values from index 0 to the specified index in the first array must be swapped, right? So basically you swap the values from the first array with the values in the second array. And they said it involves two arrays. And if you notice, if you look at this example, right, you can only swap two arrays if they're of the same length. So you see, this is 5. This is 5 numbers. So they're of the same length. So I'm going to create a function void recombination. Then I'm going to take in two arrays. So I'm going to call it, I'm going to say array 1, right? ARR1, or you can say array 1, that's fine. Then comma int array 2, right? And then comma the length. And I'm going to pass one length, right? Why am I passing one length? Because remember what I told you. These two arrays, in order for us to do the swapping, they need to be of the same size or the same length. Then if you read the practical again, you see that they told you that the user will have to specify an index. That means we need to take in another thing, which is an index. So I'm going to pass here an index. To be honest, you don't actually need the length here. Yeah, you don't. because we are only, remember the length, right? You only pass it if you want to go through the whole array. In this question paper, right, we have the index and they told us to use that index. So that means we start from 0, then we stop at that index that was given by the user. So that means we don't need the length. So I'm going to actually say index. So int index, because that's what the practical says, right? We don't need to go through all the elements in the array. So I'm not going to pass length. Then we're almost done. We just left with one more function. We see our functions, right, to set up array and do all of the stuff. It's there, everything is there, right? But then there's one thing that's missing. We are missing what? The function to display our array. The user needs to see the array, right? So I'm gonna say void display array. And like I said, use verbs. You see the word display, it's an action followed by the thing you want to display, an array. So I want to display an array. So display array. I know you might ask yourself, but say we have two arrays. So do I mean I pass two arrays? No. You need to be smart. Think. This display function does the same thing, right, for both arrays. So you should only take one array. Then you call it twice and then you pass different arrays. So I'm going to skip int arr square brackets and then the length. I'm taking in the length because I want to print all the numbers. Then I'm gonna copy all of this, right? When you do your implementation, you need to also copy them in the namespace. Select all of this, then right click and say copy. Then go to my CPP file for the one that is the same name as my header file. Then I'm gonna paste it here and click paste. Then I'm gonna go back to the top here. Before you continue, you need to include the header file. So include header file. And we're going to use double quotes because we are the ones who created the header file. We are not getting it from C++. So lib evo alg.h. And we're probably going to need to use the namespace, right? So I'm going to say using namespace standard because we're going to be printing. Remember display, it's going to use cout. And then we're also going to generate random numbers, remember. So I'm going to need to use the ctime library, which is part of C++. So I'm going to use angle brackets to specify that. You see, this is less than and greater than symbols. We call them angle brackets, just like angles in high school. So they're called angle brackets, right? So these two things, right? They're called angle brackets. You should know your English because when you go to the industry, they'll use those same terms. So you can't act like you are stupid and you have a degree. It makes no sense. You can't be having a BSc degree and you fail to understand this basic terminology. So you should understand those words. So now we have the ctime library, right? So we have the ctime library. Then what I would do is so now before you continue, this is the implementation file, right? So you need to implement every function. So every function, you replace the semicolon with curly braces to define what we call scope. We did talk about scope. So I'm going to press enter to remove that the semicolon, then put curly braces like this. I know some people, they do it this way. The curly brace is on the same line as the name of the function. That's up to you. But to be honest, it should be like this. It's easier to read in that way. Then I'm going to replace this semicolon with this. Then with this, and then with this, right? So these are all my functions, but just be careful. Let me see if I didn't remove the curly brace. Yeah, I did remove it. Yeah. So how do you know if a curly brace is missing? You see, when you click on it and it becomes red, it means that there's a closing curly brace that's missing. So I'm gonna go down here and put the closing curly brace. You see now it's no longer red, it's now black, meaning that it has a matching curly brace. And the reason why I write it this way, right, the curly brace, so that I can see which is the opening, which is the closing one. Because if it's on the other line, I might lose track and not know which is the opening curly brace, which is the closing one. So now let's do the setup. Before we do the setup, we need the IOStream library. Yeah, we're gonna need the IOStream library here. So I should include IOStream. I think we're gonna need it. Yeah, we're gonna need it because C in and C out, they're part of IO stream library. IO stream, remember, I stands for input, O stands for output, stream, and it uses streams to achieve that. So now there's something that I want you to teach you, right? The technique. If you want to create a function whereby it shouldn't be, most of the time it shouldn't be able, you can, I'm not sure, but we can test it out. But there's sometimes there's functions that you don't want to be to export them, right? There's some functions like that. You don't have to include them here. You can only declare them here inside this namespace. So let me create a function called generate random numbers because remember we need to generate a random number. That's what the practical requires us to do. These ones and zeros, you need to initialize the array with random numbers. And it can either be a 1 or a 0. Then now I'm going to say create a function. And this function, it's a 1 or a 0. And what data type is a 1 or a 0? It's an int. So this function will give me back an integer. Then I'm going to call it generate random number, right? You can call it gen ran number or number. I don't know, but I like to use full words so that it's easy to understand the purpose of my function. So this is the generate random number function. And it's up to you, right? You can pass here, right? You see here, you can pass in the bounds here. That's up to you. By bounds, you know maths, right? Bounds, upper bound and lower bound. That's up to you. Just to demo, just to make sure that you see that either way approach it, either way it's gonna work. I'm gonna use the bounds. I'm gonna say int, this is my lower bound, comma, it takes in an upper bound. Right, so it takes in two parameters or two inputs, a lower bound, meaning a starting point, and an upper bound, which is a stopping point. It's up to you whether it's going to be inclusive or exclusive. That's up to you. Then we need to find what we call a range, right? So if you remember we did talk about random numbers. I think I did talk about it. You remember when you're finding random numbers, right? No, I think it was ComSci to A students. Yeah, we need to cover it again. But for now, I'll just give you a short description, a short explanation. So if you want numbers between 1 and 3, let's say 3, and it's inclusive, I'm using square brackets, you see, meaning it includes 1, it includes 3. If I use round brackets, that means excluding. This is basic maths. So how do you find the range, right? Basically, the range, in a way, you can view it as like how many, yeah, basically how many numbers can you generate. If you look at this sequence, right, this range, that means I can get numbers 1, 2, and 3, meaning exactly 3 numbers. So how can I find out? How can I get to that conclusion that it's 3 numbers that can be generated within this range? It's simple. The formula is simple. So I'm gonna find the range, right? And then the range will be the formula is simple. You take in the upper bound, which is 3, right? Upper bound, and then minus the lower bound, which is 1. Then this will give you an answer, which is not what you want. Remember, this is 3 numbers, right? So basically, the answer that I'm expecting to get is a 3. And then you see this will give me back a 2. So this will give me a 2. To get a 3, what must I do to 2? I must add a 1, right? So I'm going to add a 1. So it becomes 3. So now I have exactly 3 numbers. And the formula holds true for any ranges. Even if you change for any bounds, right? You can change the bounds. The formula holds true. You need to always add back the 1. So our formula is that you take the upper bound minus lower bound, and then you add the 1 to it, plus 1. And then you have your range. Basically, how many numbers can be generated. Then now you make this function return a random number. So how do you return a random number? You call the rand function, right? Is it which header file is it part of again? Is it ctime? I think it's either ctime or cstdlib. We'll check. So this is the rand function, right? This random function, it actually just doesn't return a number within the range that we want it in, right? So this one, I think it returns a number between 0 and 1, which is not what we want, right? We want it to be in between this range, which is between the upper bound and the lower bound. So how do we do that? We basically divide it by the range, and then we find the remainder. So to find a remainder, use the modulus or percentage symbol, which basically does integer division, then it finds a remainder. Then if you want it to start at exactly 1, so now what is it? You see this formula over here? This is what it does. If your upper bound is at 3, if you remember this, the numbers that we're going to get is 3 numbers. So that's a 3. So what it will do, it will generate numbers between 0 and 3 because now you've divided by the range. But what if our lower bound is not a 3? How do we fix that? We fix that by simply adding a lower bound here. So we're going to say plus lower bound. This means that it's now going to say 0 plus the lower bound. Let's say our starting point is 1. So it's going to say lower bound is 1. And then our stopping point is 3. And then it adds the 1 to 3, which gives you a 4. So it's going to generate numbers between 0, 1, and 4. But then I think the 4, it always excludes the upper bound, if I'm not mistaken. Yeah, it's going to exclude the upper bound, meaning excluding 4. So basically, in other words, it's 1 to 3. But we need to say 1 to 4 so that it generates the number within that range, 1 to 3. So that's the formula, and then you're done creating the generate random number function. Then they told you that this function setup array, to initialize our array, it needs to go through each index. Basically means going through the whole array. So I need a for loop for that. So for int I is equals to 0, I is less than length, right? Because the length tells me how many positions or how many numbers are in the array. And then I plus plus so that I move to the next position in my array. Then now I need to index, basically go into each box at each position, if you still remember our previous tutorials. So you put in the name of the array, then you specify square brackets so that you go into the position to find that box or that variable. Then they told you that at each index, if you remember the practical, right, it says at each index, right, or each array will be made up of random numbers that are either 1 or a 0 at each what index. So it's at each index. So I'm gonna go here and then I'm gonna say generate and call the generate random number function, right? Remember this function returns an integer, it returns something. And our array, this array, at each position, it is what? An integer. It stores an integer at each position. So this is perfectly fine. It won't complain here. Then I need to pass in my parameters, which is a lower bound and an upper bound. You see, it turns blue to tell me what's the first parameter. You see, it's blue. It means that I need to pass in the first parameter, which is the lower bound. So they said it's the number between 0 and the upper bound. If you use 1, it's not going to work. It's going to generate only numbers between 0, only 0 instead of 1. So we need it to generate numbers between 0 and 1. So I'm going to actually pass a 2 here. The upper bound is going to be a 2. Because remember we talked about this part over here, right? That you need to always add a 1 to the upper bound so that it generates, including that upper bound you wanted to include. So if you want to generate numbers between 0 and 1, you need to add an extra 1 to the upper bound so that it's between 0 and 2. But then it will actually generate the numbers between 0 and 1. It always excludes the upper bound, but it includes the lower bound. So basically the formula would be like this. It includes the lower bound, but excludes the upper bound. So the upper bound is going to have a round bracket to show you that it's going to exclude it. So that's why I always add a 1 to the upper bound. So that, no, is it lower bound? Oh, no, no. Yeah, but yeah, we need to add in a 1. We'll test it out now. So I have the setup array. Yeah, but the last time I checked, you need to use it to add an extra 1. So it's setup array. It's done. You see this part? This is done. Simple. It's done. You're done with setting up the array. It's finished. Now you need to scroll down to recombination and mutation. So I'm going to do display array, right? Which simply means going through my array. So starting from this position 0, while I is less than the length, then I'm going to print my array. So the array, the way I want to print it, right, it's up to you. You don't have to do it the way I'm doing it. I want it to have like this. I'm going to put it as a comment. I want to have the first value. Let's say it's a 0, comma, and the space, followed by the next number, comma, and the space, followed by the next number. Then a closing square bracket. So in order to achieve this in C++, you need to output the opening square bracket first. Before you remember, everything you do in a loop is going to be repeated. If you put it in a loop, right, your output is going to be weird because now you're going to have square bracket, you're going to have opening square bracket and the number, comma, and a square bracket, opening square bracket and the 1, comma, and a square bracket again, and the next number, let's say it's a 0. You see that this will not be what I intend to do. Because you look at here, there's only one bracket, so I should do it outside the loop. So I'm going to say C out outside the loop, a square bracket. It's up to you how whether you use, I think you can use this. I think you can, because it's one symbol. I think you can use the char. I would like to save space a lot, so I would reuse the char and don't put end line here, because if you put end line, let me show you what end line does. I guess this will be the opening curly brace, opening square bracket. Then you put end line, then it's going to do this. That means you're going to have a square bracket on its own line. That's not what we want to achieve. So I'm not going to put the end line. Then now I need to repeat these two patterns. You see, I display the number first, then I display a comma and a space. But then the space, right? You see the comma and the space, these two things, they should be only displayed if there's a next number. You see here when there's last number, I don't display the comma and the space. I'm sure you noticed, right? So I should also do an if statement somewhere in my loop. So the if statement that I'm going to do, right, I'm going to check if you check the indexes, right, let's look at the indexes. This is index 0 or position 0. This is position 1. This is position 2. And the position is always equals to the length minus 1. So that means you see this number, you see how many numbers do we have here? It's 3. So my length is 3. You see 2 is basically 3 minus 1. And this holds true for any number of elements. So if I have 4 numbers, this will be position 3. So I have 4 numbers, so my length is 4. The last index is 3, which is 4 minus 1. So it holds true for any number, for any length. So that's the formula I'm going to use. So if my current position, which is I, because I'm looking at the position, if my current position, right, is equals to, I need to check if I'm actually at the last index. If I'm at the last position, right, this last position, which is length minus 1. So if it's equals to length minus 1, then I'm going to simply output the number at that position. I won't display the number and the comma and the space. No, I only display the number itself. You see, there's only one number. So I'm going to say C out ARR at index I. Done. Don't put end line, because do you see an end line here? There's no end line. So just simply output that number. Then else, I need to put an else. Else, if I'm not at the end, at the last index, right? What do? I display the number first. So I'm going to say C out ARR at index I, then followed by a comma, right? So I'm gonna have to use a string this time around. So okay, it's up to you how you do it, but I would advise you use a string to save your time. So comma, and then after the comma, do you see that there's a space here? So I need to put that space. So after the comma, I'm gonna say space. So that it has that space over there. Then semicolon, no end line. Then after the loop, because after displaying, it's going to keep on repeating this for all the number of elements that are there. After the loop, don't forget to display your closing square bracket. So I'm going to say C out the closing square bracket. Then I'm also going to output an end of line character, because now I'm done displaying my array. And then this is the code for display. If you want it to be in this format, right? Then we are done doing that. So I just want to do a quick testing, right? I want to do a quick test here. So I want to hash include my lib evo alg.h, and then I'm going to say using namespace ea space, because I want to keep typing and specifying which toolbox am I getting it from, or which namespace am I getting it from. That's a lot of code. Then I'm going to need to ask the user to enter options and things like that. So let's set that up. Because of time, right? I'm not going to be explaining a lot of things here. So I'm going to say char ch option, initialize it to nothing, which is just basically null, which is nothing. Then we're gonna create a do while loop because it needs to run at least once. So do while what? My ch option is not equals to x, right? So ch option is not equals to x. So I'm going to use the toLower function, right? So just keep that in mind. I'm going to use the toLower function. So I don't have to pass it here, right? I'll just use the toLower function. So I'm going to do this. I'm going to output, right, to the user, and then they're going to have options, right? So let's see. Number one should be to do mutation, perform mutation. Number two, recombination. Then there's exit. Then there's displaying. Then there's exit. So I'm going to have option A, B, C, and X. So option A, perform mutation, right? And then I'm going to put an end of line character there. Yeah, then I'll just simply continue typing here. Then I'm going to put option B, which is perform recombination. \n, then option C. It's up to you how you name the options. It doesn't really matter. As long as you can see this is A, this is B, this is C. Display arrays. And then option X, exit the program, right? Semicolon. Then, yeah, I'm probably going to put an end of line character after that so that it's easy to read. Then I'm going to, after outputting this, right? So let me show you my code. Since it's going to be an infinite loop, you see it's going to keep on repeating. It's an infinite loop because, yeah. So now I need to get input. So I'm going to do this. I'm going to say, before I do that, I'll just say, come on. I'll just say cout to just output to tell the user which they should start enter. So enter your choice. Then space, no end of line character because I want them to type on the same line as that string. Then cin, I store it inside the option variable. Ch option, right? Why is not auto-completing? That's fine. Then I'm gonna convert my ch option to lowercase. So I'm gonna say ch option is equals to lower. To lower is part of the cstdlib library, right? I think it's cstdlib. Yeah. So I'm gonna say hash include cstdlib. I think it's part of the cstdlib. Then to lower, right? To lower. And you see, do you notice something here? I want you to pay attention here. It returns an integer. So you have to cast it back, whatever you have to cast whatever this function returns back to a char, because this is a char. You see, it's a char, it's a character. So this is int. Then I need to pass in the character that I want to convert to a lowercase. It's up to you. You can use to upper or to lower. But then this function returns an integer, so I need to cast it. So I'm gonna do what I call static casting. So static cast. Then you pass in the data type that you want to cast it to here, or data type you want to convert it to, which is a char. So I'm gonna say convert it to a char. In round brackets. Within the round brackets, you put the thing that you want to cast to a char, which is the toLower function. That's why I'm pasting it there. Then it's going to cast it to a char. Then after it is casted to a char, now I can do my switch statement. So switch ch option. Now I know ch option is in lowercase. Then I'm gonna have my cases in lowercase, right? So case smaller, small letter, small case a, right? And then lowercase b, and then C is display, right? Did I say C? Yeah, it's a display array. So break. Then, okay, let me do this. Case X. This is to, yeah, case X, right? Case X is kind of a weird case, but I'll show you why. Because you need to leave the loop, right? For case X, right? What I'd advise you to do is to simply not put it because we're handling it here. So you can just simply ignore case X. So we're gonna leave case X. Then we're gonna have a default, which is gonna output an error if it did something wrong. So see error incorrect option chosen, right? \n. Then we need to do cin ignore, cin clear, and all those things. So yeah, let's see. We need to first step would, because it's gonna go into a fail state, right? You don't have to be honest, it doesn't actually go to a fail state. No, not really. But we need to, yeah, not really a fail state, but we can do it. So cin.clear and then cin.ignore, so that we delete all those characters, right? So cin.ignore the first 200 letters until you see the \n, right? And then that's done. Default is done. Then let's go under C, which is display array, right? So I'm gonna call the display array function. Then I'm gonna pass in my array. Since there's two arrays, I'm gonna have to call the display array function twice. So I'm gonna go back to the top here. I'm gonna create my arrays. So int array 1, and then I specify the size here. Basically, how many numbers, how many elements are in the array. So to specify the size, you're going to create a constant, of which you create the constants outside the main function, not inside the main function. So I'm going to say, I'm going to call it array size. You could have put it in a, to be honest, right? You don't have to do this. Let's do this. Let's put it in a namespace. You could have declared it inside your namespace here, right? And say it's equals to 5. Then simply call it that side, because you're also allowed to declare variables inside the namespace. So array size, right? Then I'm going to have the second one, array 2, then array size, because they have the same size. Remember the practical, they are of the same size. Then before we even use our arrays, we need to initialize them with random numbers, right? So I need to call I call the setup array function, the setup array 1, and its size is of size array size. So I call setup array function again, which now I pass in the second array, which is array 2. And it takes an array size because they're of the same size, remember. Then these are my arrays, right? This is my setup. And they said they need to see the before, right? The before and after. So it's up to you how you do that, but that needs you to have a deeper understanding to do that. But let's do it. So I'm gonna have call display array functions here, right? To display before. So I'm gonna pass array 1 and its size, array size. Then I call display function again. Remember, we have two arrays here, so we need to display both. So if you are displaying, you call it twice. If you're initializing, you call it twice, because we have two arrays. Then display initial arrays, right? The initial state. Basically, before we perform changes or do recombination, how does it look? But then it's up, to be honest, right? You don't have to do that. Yeah, let me think. If you're using common sense, you don't do this, right? The tutor is the one who must start by displaying the state, displaying them first. Basically, you must choose option C. You don't have to do all of that. Let me simply copy and paste this uh, lines of code so that I don't type. Now I'm running out of time because we're supposed to have a session at 8 with ComSci 2A students. The thing is, you guys tend to finish classes late, so we can't start sessions at 6. Displaying, so option C displays both arrays, right? That. But it's you don't have to do this, but let me do it. Let me say see out and say this is array 1, right? Just like that. Then here, I'm gonna just simply output see out, this is array 2. So that the user knows difference, that this is array 1, this is array 2. Then we are done doing that. So now we can do recombination and whatnot, but I think you kind of get the idea, right? Now let's introduce the changes you'd make. You guys have the memo. I don't have to explain this recombination and mutation. You have the memo. Just simply copy and paste the memo. That's how simple it is. But then use different variable names. So name your arrays differently. Maybe see, I've called it ARR. That's what I've called it. Maybe you're gonna call it int array. Because if you guys use the same names of arrays, right, and same names of variables, it's gonna say you've copied each other. Then you get a 0. And at UJ, if you get like three practicals that are written copy, you're gonna have a very nice meeting with Dr. Stung in his office. Then they're gonna discuss your future. So I wouldn't advise going to that office. Name your things differently, be unique. Even if I send you the code, do your own thing. Don't write the same names. Copy, it's fun, right? It's easy. I don't know if you've noticed things that come easy in life, they go easily too. So make sure you don't just copy and paste. You change it to your own to accommodate your own thing. They want you to now use dynamic arrays. So it's the same code, same thing, but simply change it to use dynamic arrays. Remember, we talked about arrays yesterday, dynamic arrays. So I'll simply demonstrate. For the new student, right, I'll send you the recording of yesterday's session. So now we are using pointers, right? So this will change to an int pointer, right? Then I say is equals to new int, right? Why int? Because it points to an integer. And then it's equals to new int, right? Points to an integer. But then you see that now I need to update my functions because these functions, they take arrays, not pointers. So I need to update them. So I need to go, wait, I think it can work. Okay, just a hunch. Let's see. Yeah, it can work. Yeah, I remember. Yeah, it can work. Yeah, I remember. Yeah, you can. Yeah, you see, it can work. Yeah, I remember. So to be honest, the only thing you need to change is here. You see this part over here. That's the only thing you need to do. Then you're done with the practical because, okay, not the only thing. I'm wrong. Not the only thing. Okay, to be honest, right? To be honest, let's do it this way. To be honest, you don't actually need to put these lines here. You see these lines over here? You don't need to put them there. You should put them inside the setup array, right? It basically takes in your array or a pointer, right? Just use pointers. But to be honest, you can sort of like cheat it because an array, remember the array, right? We talked about the array. The name of the array stores a pointer to the first element. So technically the array is a pointer. So that's why my code doesn't crash because technically it's the same thing. But if you pass it as an array like this, when you try to use the new keyword, it's not going to work. So we need to change them to actual pointers. So pointer, or we can try it, but I doubt it's going to work. Let me demonstrate it. Let's see if it's going to work. So setup array. Before we generate the array, right, we need to instantiate it. So let's try to instantiate it. So array arr is equals to new int length. But I doubt it's going to work because we need, maybe it might. Let me see. Build. It does work. Like I said, remember the name of the array is the name of the array, it represents a point. So this is technically a point, so it's fine. It works 100%. But I wouldn't leave it like this because you're gonna confuse yourself, or I'll just expect you to have a, let me open code blocks. I don't know whether it's because I wrote spiritual things or what. Yeah, just use pointers, but technically it should work. Technically it should work. This is close project. Can't do. Why is that showing the recent project I created? What's going on with code blocks now? Hey, you see this thing of having old laptops. Hey, I need to get a new laptop, right? This is not it. Now I can't find what I just, it's not showing in code blocks. It should be showing because it's a recent project. Yeah. I should conjure this thing. Hey, it's annoying. Yeah, there's this issue of importing. Let me quickly fix that. Come on. Yeah. So, so most of the time when you have header files, right, and you open your code blocks, it doesn't show them here. You see, it's not showing them, which is a problem. So you simply right click on the project name, then you go to add files recursively, if I'm not mistaken. And then I think it's not add, yeah, it's not recursive, it's the first one. So you're gonna say add files, the first one. Then you select all of the files, right? So it's up to you. You can add one by one, but me, I know how to add multiple. So I selected two files, the header file and its CPP file. Then I click open. Then I make sure all of these options are clicked. Then you click OK. And then now it now shows inside the code blocks. I don't know why code blocks does that. That's why I prefer Visual Studio. Visual Studio wouldn't have these issues. So let's change this to pointers. But at the end of the day, an array is a pointer, right? Still a pointer, but I would assume they want you to use pointers as parameters. That's what I would assume. Trust me, this thing is there's only slight difference. The practical is actually the same as previous practical. The only difference is that you change them to pointers, the arrays. You see that I didn't change my functions. You see that the only thing I changed is to convert each array to a pointer because it's now a dynamic array. Then I'm gonna go here. Then I'm gonna change this to pointer, right? And now since remember this is a dynamic array, meaning it's not fixed. So to be honest, this is not needed, right? Because we're not having a fixed length array, but it's still fine. We'll leave it. We'll work with what we previously had. That's still okay. Come on. Then change this to a pointer, change this to a pointer, change this to a pointer. Yeah, don't be surprised by why do I know code so much? It's experience. I've been coding since 2019, so yeah, you can imagine. I was just like you too, guys. I didn't know code. I didn't even know how to switch on a computer. So yeah, hard work. Yeah, you can ask your question, Laura. You can unmute and ask your question. Yeah, so you see the setup part, right? The only new thing introduced in the setup function is the initialization of the array, which is this line. That's the only new thing introduced. The rest of the code is exactly the same. Laura, you can ask your question. I said unmute.
Yeah, I wanted to ask why are you removing the square brackets when you changing the function to a thing to a pointer when changing the variables to pointers?
Yeah, because your practical now uses pointers, so you should pass pointers. Remember, dynamic arrays are just pointers, so you should actually pass pointers. So that's why it'll work, right? To be honest, it'll work. The same, you don't have to change. To be honest, you don't have to change anything. You can just simply pass the pointers, and it's gonna work exactly the same way. But in your code, you need to, if you're choosing that approach of not changing anything, don't forget in your setup or initialize array function to actually initialize the array. Else it's not gonna run. So be very careful of that. So now I hope that answers your question. And then since these pointers, right, they're not pointing to anything at the moment, right? We set them to null pointer. Is your question answered? Can you hear me, Laura? Is the question answered? I assume it's answered. I don't have time. So this is the two functions to initialize. But if you
No,
remember,
it's not.
what do you mean? Can you repeat what you say?
My network is breaking. I was saying my question is not answered because when you scroll down there, agree we had a variable and square like brackets to show
Yeah.
that maybe it takes a value at a certain index. But
Uh,
then now that
it,
we
yeah.
yeah, but now that we made them pointers, we removed the square brackets that came after that ARR. I wanted to ask why do we have to do that?
The square brackets, they're not necessary. The square brackets, you only use them when you have fixed length. When you have dynamic arrays, they're just pointers. So you can there's two ways to use it, right? You can leave them as they, like I said, I'm gonna repeat again. You can leave it to the square bracket, it's gonna work. Me, I choose to use pointers so that they see that I know the difference between dynamic and fixed. It's still arrays at the end of the day. But now I just choose to pass them as pointers. because it's gonna work the same way. Because you see here, I'm indexing, right? Like a normal array. And it's not complaining, there's no errors. If you see on a build here, it's not complaining, no errors, none. So either way, either approach, you do what works for you. Me, I do what works for me. You do what works for you. If the square brackets work, leave them. Your solution shouldn't be one thing. There's no one way of doing it. Unless, but then they might ask you, that's the thing. If you're gonna use square brackets, the tutor is gonna ask you, why did you leave this to square brackets? That means you need to understand how arrays work and to know that an array is actually a pointer in a way. So you need to explain yourself thoroughly. So yeah, I hope that now answers your question. So we have these two pointers, right? We initialize them to nothing, null pointer, because they're not pointing at anything at that point in time. No pun intended. Then you call the setup array, which is going to set them both of them to now point to some array on the heap, right? And we called it for both arrays. So we have initialized them. But then now we need to add one more function, which is to destroy. We did set it up, right? We need to destroy. So I need to create one more function. So void, I'm going to call it destroy or deallocate. You can call it deallocate. It needs to take in our array, which is that pointer. And since we're only destroying here, we don't actually need to pass the length. To be honest, we don't. You'll see the code inside the function. Then I'm going to go inside here and right before this closing curly brace for my namespace. So I'm going to say this is where namespace ends here so that students can see my code. I don't know. Since you guys are beginners, you tend not to see things. So that's why I'm going to put comments to show you this way it starts, this way it ends. So this is where namespace starts. So that you see that my code is in between the names, the curly braces for the namespace. Then here to destroy, we did talk about it. I'm not going to explain. So we delete square brackets because we put square brackets to tell C++ that we're deleting more than one item. Then we now make it point to nothing. So that if you try to access it, it's going to throw a segmentation fault error, meaning that you are trying to do something that's illegal, so that the user knows that, oh, I'm trying to do something that's illegal. Then here I'm gonna have a comment that says free memory, right? Or in other words, you can say this is deallocation. So I need to call the destroy method and pass in the both arrays. So I call it first. Remember this, you need to understand something about functions, right? When you declare your functions and you say that it takes in one array, it takes in one array. Don't do spiritual things and pass two arrays. It's gonna crash. If you want to work with two arrays, call it twice, two times, because it takes in a maximum of one parameter, one array. So that's why I'm going to call it twice here. So destroy, I call it again, array 2. Then it cleans up or frees up the memory once it's done being used. And then that's pretty much your prac. So the only new things you're going to introduce is pointers. You see this part, you're going to make them pointers, set them to null pointer, then add one line in your setup array function, then create a destroy function to destroy, then change every square brackets and replace them with a pointer, or you leave them, the square brackets, it's fine. You can leave them. You choose what works for you. Yeah, you can ask a question.
I wanted to ask, Hori, since the user has to input an array size, do we just initialize it without a value like inside the header file and like everywhere else?
Yeah, well, that's what I did. Do you see the code? Is there any way whereby I use array size? Let me show you the implementation. You'll go, I'll zip it and send it to you guys in the group. You'll check. Do you see is there any way where I've used array size here? Nope. I'm using the length parameter that's being passed, meaning it can be any number. You can get it from the user, or you can. Here, I'm using a constant as an example. You can, instead of using that constant, you can say cout, get the size from the user, then store it into a variable called length, right? C in length, then you pass length here. You do all of that. Me, I'm using this as an example. Functions, they mean it takes in in that parameter. It takes in that value, whether that's a const, whether that's a value from the user, doesn't matter. The function, all it knows is that it takes in some array size, some length, or some integer as a second parameter. It's up to you. The thing is, I didn't, since I'm doing things in a rush, I forgot about that option. I don't know whether you're supposed to ask the size from the user or what. However, this must be, let's see. The functions must, okay, you must implement the same program. Yeah, they didn't talk about getting input from the user here. I don't see it. You must follow the instructions. If they say it, then do it. They didn't say it. All they said is that you must repeat what you've done in the previous practical. That's why I'm also using that const that we used on the previous practical, because that's what we did in the previous practical. But they know, trust me, these people, they're doing honors and masters and PhD. You don't have to explain anything. Just write code. But they might ask you to and see if you understand. They know what they're doing. You don't have to worry about them not understanding. It'll work either way. And if they ask you why didn't you get input, you'll be like, where in the practical does it say I must get input? There's no way it says so. So that means it can either be a const that I've created myself, or I get the value from the user. But if it was written that I should get it from the user, I would have done that. But now it's not written, so and it's not even in the mark sheet. The main important part is the mark sheet. If it's not in the mark sheet, then if the mark sheet was written that get the array size from the user, 5 marks, then you would have to do that. Or if it did say it here at the top, somewhere here, it didn't say it at all. So don't put something they didn't tell you to do. Just use constant. They literally told you you must implement the program based on practical 6. That's why I opened practical 6 and I just did practical 6. Then I showed you the few changes. Like I said, this practical is easy. Don't overthink. You overthink, you start answering your own questions. This practical is straightforward, very easy, easy peasy. You do it in 2 minutes even. Because the only thing you need to change is that it now works with pointers, then add one more function to destroy. Then if you want to replace the squares with pointers, you can do that, or you can just leave it as it is. So like I said, this practical is very straightforward. Then you guys are given the memo. So you just need to work with the memo. Copy and paste the memo. Or if you got 90 something or 98 in your previous practical 6, just use your solution. So yeah, don't overthink this practical. Don't make that mistake. Don't overthink it. They didn't talk about options, what, getting it from the user. It's up to you. It's optional. You do. In this case, I wouldn't advise you to get the value from the user. I would advise you to just use the constant because they said it should be based on practical 6. But if you feel the need to get the size from the user, you do that. You do what works for you. At the end of the day, this practical is meant to demonstrate pointers. That's all. They just weren't going to look in your code. Oh, there's a star, there's a pointer. So this student used pointers, then you get your full marks. As long as it still does the recombination and the mutation, you get your full marks because the main goal is to use pointers. How you initialize the array, they don't care. Did you initialize the array using pointers? Cool. You get your marks. Whether you use a const or you get it from the user or you do what doesn't really matter. All they need to see is this destroy. That's the main important part. To destroy, I think there should be marks for that. To destroy. Oh yeah, there is. The dynamic memory allocation, there's 20 marks. So this is how they're going to mark. Let me show you what I mean by some things they really don't matter. You see the mark sheet, it says dynamic memory. Where's the allocation? They're going to go to your setup function. So this part over here, right? You see this part over here? It's worth 20 marks. That one line. So some things are not important. Then they're gonna look for the deallocation, which is your destroy method. Then they go down here. They give you 20, they see it here. So you get 20 marks for that one function. Then you get 20 marks for recombination. You get 20 marks for mutation. Done. There's no thing about input, output, what done. Does it do the recombination? Does it do the what? Okay, it has output, but that's not the main important part. Things like memory allocation does still do all the things. Basically, you're just redoing previous practical, change the dynamic array to now use to change the fixed size array to now use a dynamic array, which is basically pointers. That's the only thing you should need to introduce in this practical. This practical, like I said, you can do it in 10 minutes max, because the only thing you need to introduce is create this destroy function, go inside your main, change the square brackets and make use of pointers. Then inside your setup array, you need to initialize or allocate your array, which is basically this new int length here. Then you need to add a destroy method, which is this. Then you simply leave the rest as it is. The rest is going to be left as it is. Your recombination functions, your mutation functions, they're still exactly the same. And with regards to square brackets, like I said, you can leave them. It's fine. You don't have to change a lot of things. You can just leave the square brackets. It's going to work exactly the same way. So yeah, that's it for today's practical. So today's session, I mean, so I'll send the code in the group chat. I need to go and attend ComSci 2A students right now because we're busy with past papers and they're writing next week, right? Next week, Tuesday. So yeah, we need to be busy now. Yeah, we'll continue with our revision tomorrow, right? We'll continue where we left off. I don't know what we're gonna cover tomorrow.